Hello. Today I want to briefly go over how to figure out the X and Y coordinates for the stars in the three different fields of the Parallax lab. I'm already sharing my screen, and I always like to start with the course homepage so I can show you how to get there from here. For the Parallax lab, we're clicking on the content, then content, and we scroll down to the Laboratories tab, click on Lab 4, Parallax. The three different star fields that you'll be reading the coordinates of for the three shifting stars per field are posted on the GSU Perimeter College Astronomy 1020 Lab website. Okay, that opens in a new tab. If you wanted to get to the lab write-up, you would click on the Astronomy 1020 Lab manual link and then scroll down to Parallax and make sure that you click on Introduction for Online Students and Lab Instructions and Questions for Online Students. Let me briefly show you where to start with the star fields. This is question 1. Start with field 1, click on its thumbnail version for the full version. Then you find, by clicking back and forth between image 2 and image 1 of the star field, you find the three stars that shift. And for each of the three stars, you will record the x1, y1 coordinates from the first field and the x2, y2 coordinates for the second image of the same field after they have shifted. The two images are taken 6 months apart from Earth's orbit, looking into the same direction in the sky. So the three stars that shift are three stars that are nearby with respect to the background stars that don't shift. So let's go ahead and do that. We'll go back to the Parallax lab, click on the website again. And this time we're going to go down, since we have one tab open with the instructions now, this time we're going to go down and look at the star fields. So here we have field 1. For each field there is an image 1, which is taken from one side of Earth's orbit, and an image 2, which is taken 6 months later from the other side of Earth's orbit, where Earth's orbit is the baseline. We have image 1 with no grid, so this would just be the picture that you would take, and then image 1 with grid, where you can read the grid coordinates x across the bottom and y vertically for each of the stars. For field 2, we also have an image with the grid, so you can read off the coordinates. Now, it's possible that we can already spot the three stars that shift simply by clicking back and forth between the two images with the grid. But if you have problems, if the grid lines get in the way, then you can always start by clicking on the two images, image 1 and image 2, without the grid, find the three that shift, and then click to the images with the grid to read off the coordinates. Okay, but we'll start straight away with the images with the grid. And the best way to find the shifting stars is to click back and forth. So what we want to do is to open each of those images in a new tab. So I've right-clicked on image 1, which is now opening in a new tab. Then I'll right-click on image 2 so that it also opens in a new tab. Image 1 is on this tab on the left, and image 2 is this tab to the right of it. Let's click on image 1, looking at the stars, and then image 2, 6 months later. Okay, so you've seen that stars have shifted. I'm going to click back and forth a little bit so we can figure out which three stars they are. And as you can see, let me click back to image 1. The stars are represented as circles of different sizes. Well, technically, when we look at the skies, all stars are so far away that they are point sources of light. so we cannot really see what their sizes are just by looking at them in the sky, but they come in different brightnesses. So the sizes here, since it's all the same shade of white, the different sizes are representing the different brightnesses that they would have in the sky. And that's how you can match up the stars that shift. So you want to match them up from image 1 to image 2 and make sure that you're tracking the same star. So we're back to image 1. I'm just going to click back and forth a few times. Image 1, image 2, back to image 1, back to image 2. And I think by now we see, back to image 1, which 3 stars they are. The brightest one is this one right here. So notice from image 1, if that's the star that shifts, then there will be nothing at this position in image 2. So let's click to image 2. So there's nothing right here. And since we have clicked back and forth a few times, we notice that's where the brightest star shifted from image 1. So there is now something in image 2 where there was nothing in image 1 before. So let's confirm that by clicking back to image 1. Yep, that seems to be the brightest star of the 3. Image 1 position, image 2 position. So you can now read off the coordinates of the first star and then move on to the next star that shifts. Let's take a quick look at what the other 2 stars are that shifted. So this was image 1, back to image 2, back to image 1. You've probably seen now that this star, which is fainter than the brightest star, wait a minute, this is the brightest star that shifts. So this one is a little bit fainter, and this is the faintest star of the 3 that shift. If I have identified correctly that these are the 2 stars that shift, there should be nothing at this position in image 2. Yep, there's nothing now where those 2 stars were in the first image, but we have stars now that weren't there in the first image, so one that is not quite as bright as the brightest one, and the really faint one. Let's see if those are the 2 other stars. So if we click back to the first image, these 2 should have disappeared and be back at their first locations. Yeah, so right here and right here. As far as the table is concerned, it doesn't really matter which of those stars you enter in row A or row B or row C, as long as you make sure that you track them correctly from image 1 to image 2 and match up the stars correctly with the first and their second position. We're just going to read off the coordinates of the brightest star as an example. We have horizontal lines and we have vertical lines. The red lines are the full grid units. You take the bottom left corner as the origin of your coordinate system. Reading from left to right, horizontally across, is the x direction. Reading from bottom to top is the y direction. We also have blue grid lines. They have much shorter intervals. They're subdividing the full grid units. The blue grid lines correspond to 0.2 of a grid unit. If I start in the x direction, reading across from the bottom left to the right, we have 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, and so on. So at 1.6, we can go up, and this is the brightest star that shifted. Now, I really leave it up to you if you wanted to call this 1.6 or if you wanted to call it 1.5 and estimate the position in the middle, or even 1.55. I'll accept any of those readings, so that's within the experimental uncertainty reading of those coordinates. So I might just go with 1.6 because it really is closest to this grid line here. The x1 coordinate for this star, we could call this star A, would be 1.6. Let's read off the y coordinate, which is from the bottom going up. We have 0.2, 0.4, 0.6, 0.8, 1.0. Now you could say 1.0 in the y direction, or this seems to be closer to the middle in between 0.8 and 1.0, so you could call that 0.9. I'm just going to call it 0.9 because it seems to be closer to the middle. But if you call it 1.0, that's fine. I'll leave that up to you. That's within the margin of experimental uncertainty. Again, the y1 coordinate would be 0.2, 0.4, 0.6, 0.8, 0.9. So then x1 for star A, we would enter into the table as 1.6, and the y coordinate we would enter as 0.9. Then we switch to the second image, and we find the brightest star over here. So this is the position it has switched into after Earth has moved halfway around its orbit. Let's read the x-coordinates. So this would be for x2, starting at the origin. First red line would be 1, 2, 3, 4. It is less than 5, so now we're going to switch to adding the blue grid lines in. So we're at 4, 4.2, 4.4. So you could call this 4.4, or since it's closer to the middle, you could also call it 4.3. Then the y coordinate, y2 for the first star in field 1, going from bottom and working our way up to the top. Let me just do that over here. So the first blue grid line would be 0.2, 0.4, 0.6. Since it's closer to the 0.6 line, I'm just going to call it y2 equals 0.6, but you could also say 0.7. We would then go ahead and enter for our x2 and y2 coordinates for the brightest star in the first field, 4.3 for x2 and 0.6 for y2. Then having entered x1 and x2 and y1 and y2 for the first star, that's how you read off the coordinates. Feel free to shoot me an email anytime if you want me to go over the coordinates you've read off. I'll take a look at your coordinates and make sure they're okay. After you've filled in the coordinates for the first table, let's go back to the lab website. Then you repeat the same process for field 2. Again, you switch back and forth to figure out which are the 3 stars that shift and track them from image 1 to image 2. Make sure you match up the correct stars with their first and their second position. And again, it doesn't matter which star you call star D, star E, and star F. So it doesn't matter which stars you label with which letter, as long as you track them correctly from the first image to the second image. And then you repeat that for field 3 for the third table. So let me know if you have any questions. Shoot me an email. We can meet in WebEx and I can talk you through these things. See you next time. Bye.